Graphs of functions. The learning objectives. By the end of this section, you should be able to recognize and plot cubic graphs, recognize and sketch exponential graphs, recognize and plot reciprocal graphs. So far in your studies, we have looked at linear and quadratic graphs. Here are some linear graphs. Here are graphs of quadratic functions. We will now look at some other functions with distinctive graphs that we would be expected to recognize. Cubic graph. A cubic function is one that has a term raised to the power of 3. They're all cubic functions. They contain a term that has been where the x has been raised to the power of 3. So complete the tables to find the values of x cubed and minus x cubed, and record your answers to one significant figure. So pause the video, do that, and then play it again once you've done it. Right, so there's the values for the first table for x cubed. And for minus x cubed. So draw two pairs of axes similar to these on the same scale and plot the graphs using the values in the table. Do that now. Once you've done it, come back and we'll compare the graphs. So here's the graph of x cubed, and here's the graph of minus x cubed. X cubed has a positive gradient and minus x cubed has a negative gradient. The cubic graph is usually described as S-shaped. When the cube term is followed by a minus x term, for example 3x squared minus 2x, the S becomes more pronounced. There's a graph of x cubed minus x. Determining the key points of a cubic function is covered in higher level mathematics courses. You will only need to be able to recognize a graph as being cubic one from a table of values. So what I'd like you to do, copy out a table of values, fill in or find the y values, record them at one decimal place, and then plot the graph. Pause the video now, have a go at that. Once you've done it, come back. So there's our values in the table. And there's the graph. It should look similar to that. And same again, copy out a table, complete the table of values, again recording at one decimal place. Once you've done that, plot the graph. So pause the video, do that, and then come back afterwards. Right, there's the values. And there's the graph. Exponential graphs. In all of the functions we have looked at so far that have had an exponent, the exponent has remained constant and the base number has increased. So for a quadratic, the value of x goes up, but the exponent remains as a 2. In a cubic function, again the base number goes up, but the exponent remains as a 3. In an exponential function, the base number remains constant, and it is the exponent that increases. So for an exponential function, k to the x, k is a positive integer, the k remains constant. It's the power, the exponent that goes up each time from 0 to 1 and carry on. So x is the value of the exponent. Key points to appreciate about an exponential function: it can never equal 0. The y-intercept is always 0, 1. Get that from k to the 0 is 1, anything to the power of 0. And it will always pass through the point 1k, because k to the 1 is k. We look at y equals k to the x. When k is minus 1, what will the value of y be? It will be 1 over k. K to the minus 2. When x is minus 2, y is 1 over k squared. When x is minus 3, k to the minus 3 is what? 1 over k cubed. That gives our y value. And finally, k to the minus 4 is 1 over k to the 4. What's happening to the magnitude of the denominator as this sequence progresses? The denominator is increasing exponentially, so it's getting bigger very fast. So what effect does this have on the actual magnitude of k to the x? What happens to the size of k to the x? It'll get smaller and smaller, but it'll never actually reach 0. It tends towards 0. It moves towards it, ever closer, but never actually reaches it. This also gives us another key point of exponential functions. It will always pass through the point 1 over k. Now, using a calculator, sketch a graph of y equals 2 to the x. When asked to sketch a graph, we are only after the key points and the general shape of the graph. What key points do we know about an exponential function? We know it can never equal 0. The y-intercept is always 1. It passes through the point 1k. It passes through the point minus 1 over k. So this gives us coordinates of points on the graph of y equals 2 to the x. So what coordinate do we get from the y-intercept is 1. We get 0, 1. What coordinate will this give us on the graph y equals 2 to the x? Well, k is 2. It gives us a coordinate 1, 2. This one, we know that k is 2, so it gives us the coordinate minus 1 over 2. So if we plot these on the graph, so we've got a start there, we've got 3 points on it. The y-axis goes up to 17. What value of x will y be around 17? Try some numbers in your calculator. Not after anything complicated, it's just throw numbers in, start off with 2, 3, moving it up until you get close to whatever the top of your y-axis is. Well, 2 to the 4 is 16, and it gives another point, which is 4/16. So we now have 4 points on this line. Join the dots with a single pencil stroke. Remember, the start point will almost be at 0. So, as with lots of the functions we draw now, we don't do it with a ruler. There should be no straight parts to this at all. It's a curve. So there is our exponential curve, the graph of y equals 2 to the x. Don't worry about the drawing of it. It doesn't have to be that, it's not that meant to be perfect. These will always only be sketches. Sketch the graph of the following functions. Use the same scale for the axes as those that are drawn here. So pause the video now. Draw them. Once you've done them, play the video and then come back. Right, so here we go. Y equals 3 to the x. The graph should look something like that. And again, we look at the general shape in the same area of the axes as this one is. Y equals 5 to the x. We're really looking at the steepness of the graph. So reciprocal graphs. A reciprocal function is one to be written in the form y equals a over x. So these are all reciprocal functions. Complete the table of values to 2 decimal places. Can use a calculator for this. So pause the video, fill the table in, and once you've done it, come back. Here's our values for the first table. Y equals 1 over x. If you notice, when x is 0, the y value, people will quite often put it as being 0. It's not. The y value is undefined, because when x is 0, it would give us 0 over 0. We can't divide by 0 ever. That is an undefined value. And for the second table, again, the value of y when x is 0 is undefined. So I'll plot the graphs again on a scale similar to the ones that are drawn here. Quickly sketch them, and once you've done them, come back and check that they look similar to these. There's a graph of y equals 1 over x. And that's the graph of y equals minus 1 over x. Lines become infinitely close to, but never touch the axes. These lines, when they never actually touch, are called asymptotes. What are the equations of the lines of symmetry? Both of these graphs have the same lines of symmetry. What is the equation of these lines? Y equals x on both of the graphs is a line of symmetry. The next line of symmetry is y equals minus x. Again, both lines of symmetry are the same for both of the reciprocal graphs. What we do now is plot both of these graphs. You're given the range for the x values. So y equals 5 over x, and we've got a range of between minus 10 and 10 for the x value. And for y equals minus 4 over x, we've got the x values from minus 5 to 10. So do that. Once you've done it, come back and we'll get the answers. Right, so once you've done it, we should get graphs looking something like this. And there's the other one. Another two for you to do now. Slightly trickier, but do them and see how they go. Again, we've got the ranges of the graph for the x values. So pause the video, work out your own values, plot them on the graph, and then come back and check it. There's our first graph, and there's the second graph. So that's it for the graphs of functions. The main thing is we need to be able to plot them and sketch them, but we also need to be able to recognize them. In the next exercise, you are to state if the graphs are linear, quadratic, cubic, exponential, reciprocal, or none of these. It's by no means all of the graphs we'll have in mathematics. So here we go. Have a look at these, have a think about them, pause the video, write down what you think they are, and once you've done that, come back and we'll check the answers. Okay, so question 1, cubic graph. Question 2 is reciprocal. Question 3 is none of these. 4 is linear. 5 exponential. 6 is cubic. 7 is also cubic. 8 is quadratic. And finally 9 is linear. We should be able to recognise graphs as what they are by looking at them. We will carry this further. We've got to do a bit more investigation to try and work out what the functions are or what the actual equations are. But for now, hopefully you found that helpful. If you didn't, go back, play through the bits you weren't unsure of, and you really need to be able to recognise all of these graphs or type of functions that the graphs